Alright, one of the things I've done is I've gone ahead on my feature manager over here to the left, and I've rolled it back to where I made my last feature to create the dragster. And as you can see right here, I don't have this rod sticking out in the front of it. But first of all, why do I put the rod in there in the first place? Well, the reason I put the rod in there in the first place is as the dragster is being milled out, one of the critical things is making sure you are accurate on the distance from this point here to that point. One of the rules that I always employ on my dragster design is friction, surface area equals friction. The less surface area I have, the less friction I have on my car. And the point on that is that if I make a smaller car, it goes faster. So I'm really very, very close to the rules on this distance. I think this year on the TSA rules is the minimum distance can be 240 millimeters. Well, this car is 242 millimeters. So to mill this out and to get it very, very accurate, I employ a technique where I put a rod that sticks out of the car and actually goes into the fixture as I mill the car out. So that way I'm constantly protecting the front of the car. Well, let's talk about how I do that. Well, first of all, to put a plane right up in here so I can create a shape, I actually insert and create a plane. And I call this plane the holder plane. Now on my holder plane, as you can see, let me click on this, make it visible so you can see it. On this holder plane, as you can see it, I put it about just a little to the front of the bushing and axle hole. And what I do at that point is, let me roll this sketch down further, roll the features down further. I put the rod in, and let me extrude that here a little bit, and I'll show you the sketch, and I'll do an edit on the sketch. So let's go around to the back end of the car, which would be right here at the back, and you can kind of see that sketch as it is. Let me turn off the shading so you can see the sketch a little bit better. And I'll also go and turn off my view. I'll go and turn off my relations in this as well. So let me actually edit the sketch so you can see that I'm actually in that sketch to edit it. And I'll turn those relations on or off. I think I can display the relations I want to here, or I can turn them off. I'll come back to this in a moment. This has changed actually in the new version of SolidWorks, so I gotta figure out how they did that. But suffice to say, as you can see zoomed up here, I draw this rectangular shape that's a little over 11 of an inch over. Now 11 millimeters over. So I draw that shape, and then from there I'll take that shape and I extrude it as you see here, so it goes out into the block. So I'm going to go ahead and do a rebuild real quick, and you'll see that extrude. And I'll go back to my shaded with wireframe edges. Now it doesn't look real good because it's going to have a tough time milling that, so I add one more feature to that to get this block prepared to mill, and that is I put in this fillet around that. The fillet helps me out as far as going over the piece more accurately, and it just looks better. That's why I put it in there. But as you can tell on the front of the car right here, we have the point is protected, and when you mill the car out and the car comes out, I'll show you some videos and pictures of it later, it comes in just fine. So to alleviate any of the confusion right now, I always go back and I turn off unnecessary things I don't need to see. So I'm turning off that plane. So what's important for you is to go ahead and draw that particular shape and then project it into, so your car in the front will be protected and you got enough material there. Now once the car is milled out, all I'll do is take a bandsaw and I'll just cut, or a scroll saw, and I'll just cut this here off, and then I'll sand it out, maintaining the protection on the front of my distance of 242 millimeters. So that looks pretty good. We'll stop here for now and come back to this in a moment. Okay, let's get started making this toolpath. Now what I want to do is go to Sketch, and I want to go to create a new sketch, and I will select a plane. I'll go ahead and expand the feature manager over in the design view, and I'll set myself normal to the right plane. What I'm going to do right now, and I'll talk as I do it, is I'm going to go ahead and I'm going to create what we call a containment sketch. And I'll just come out to somewhere around here. I'm trying not to snap on any points, and I'll come out here in space, and I'll come up and I'll draw in roughly what looks like a CO2 Dragster block. And the only thing I'm really concerned about is this part right here. Now it's important to understand, what is the size of CO2 block? Well, CO2 block is 305 millimeters. So I just key in 305, hit enter, and it'll expand the block out accordingly. Now what I'm going to do is I'm going to go half the diameter of my milling bit. My milling bit is 1/8 of an inch, so half of that diameter is 1/16 of an inch. So here's where I switch. I'm going to go from millimeter gram scale into inch pound second. The reason I'm doing this is 90+% of all American parts that are made in the US are made using inch pound second. They use imperial or English units to actually do milling in most of the machine shops. I'm doing this where we switch from millimeters into inches so that you'll be understanding of that process. Now more and more companies are going to actually mill in metric, but for now I want my students to be bilingual and they're able to do that. So let's go back to that sketch real quick, make sure that we're editing it, and we'll come in and we're going to set a smart dimension off the back end of the car here, and we're going to say 0.0625 is our actual distance, and it'll bring it up to 0.065, which is 1/16 of an inch. So our milling bit will come up to this edge and it will stop, but it'll actually take off any material that's on the end of the car, so that's good. Now the next thing I'm going to do is I'm going to go bilingual here. Okay, so in this, because I'm thinking of the CO2 block, I'm going to key in 70 millimeters right here in mm, and so that'll put it in at 70 millimeters. Now critical part on this is the same thing over here. On this dimension here, I'm actually going to go a distance, make this dimension driven. Let's get out of that for a second and see what's going on here. That should work. Let's do that. We'll come down here and we'll set a dimension from there to here, and we're going to say on that dimension we're going to say let's say 0.25 of an inch, so we'll say 1/4 of an inch. So we go 1/4 of an inch where the tool path comes up. Now let's look up front here real quick. Again, we got to find out where 20 millimeters is. So I'm going to go here in the front, key in 20 millimeters because that's the shape of the block. So as you can see, I'm mixing dimensions as I'm actually making this car. Well, that's causing me to make a change because this is way too close here on the contain, and I'll come back and I'll set this to 0.12. Let's go 0.125. Let's see what that does. That does give me some clearance up here, so that's good. So, and also gives me an extended link up here in the front, so that's really, really good. So here's what we're going to look like when we mill this car out. The block will actually come up to about this point, as you can see, and let's make sure this is set to 305 millimeters just to be on the safe side. Make sure that's 305 mm, so millimeters. So that's good. Yeah, 12.0079 is obviously that distance. So this is the millable area so far where we can mill our car in. Well, there's a problem here. The front of the car, you do not want it going all this way up here because the actual CO2 holder, CO2 fixture holder, dragster holder is going to come right up in here. So if we say this is the millable area, it's going to crash right into that and bust the aluminum, break the bit. We don't want that to happen. So how do I solve that? Well, it's pretty simple. So what we're going to do is I'm going to first delete that one dimension because once I've set it, it's already set, but it's still the same size. So I'm going to delete that dimension. Now what I'm going to do is I'm going to come over here and I'm going to draw a line out here in space. I'm just going to go vertical. I'm going to go, we'll define our own distance. So I'm going to come up here to there. Now what I'm going to do, I know my car is about 242 millimeters. I'm going to come up off the front of this and I'm going to set a dimension off the very tip of the car to right here, and I'm going to say 0.375. This is just kind of a look and see what the clearance is. Actually, that's pretty good. I'm going to go a little shorter and I'm going to say 0.516, 3125, and let's see what that looks like. It looks pretty good. It looks pretty good. I could give myself a little more clearance. Let's go to 0.275. And what I'm doing basically is I know the diameter of the tool can penetrate past this area here and give me an opening. I'm just trying to give myself more material that's going to hold the block more stable into the CO2 Dragster fixture. I like that. I'm going to go with that. So now I'll accept that. I'll go ahead and do a quick rebuild. And then I'll go back to a right mouse click on that sketch and I'm going to edit that sketch. And first thing I'm going to do is a power trim. Power trim lets me cut lines I don't need anymore. So I'm going to take that one out, take that one out, take this one out, and I'm going to take that one out. Okay, so now I've got the area upon which my milling bit will actually go, and it's called the contain area. So if this is called the contain, let's go ahead and name it contain. Okay, so I always give myself feature information that I can understand. So I've got that done. I'm going to save this file, and we'll come back to this and start on the next video on putting in what's known as the offset.